Okay, here we go with polyatomic ions. Yet another reason why life is good. Now, they're called polyatomic ions because the word poly means many, and we're talking about many atoms. The ion refers to the fact that those atoms have a charge. So polyatomic ions are like a package deal, many atoms with a charge. Now let me show you the first polyatomic ion, first and the best, and that's the ones that are made with chlorine. Chlorine's got 7 valence electrons, and here's where they come from. Chlorine's electron configuration is 1s2, 2s2, 2p6, 3s2, 3p5, and valence electrons are the outermost s and p electrons, so he's got 7 of them. Okay, so you put the 7 valence electrons around chlorine, which makes it obvious that he needs one more. Now these are called oxyions also because they're mainly the anion, which would be chlorine, and oxygen. And oxygen needs 2 electrons. So what's going to happen is oxygen's going to share with chlorine on one side. And that's good. It makes chlorine's life good. But oxygen's going to steal the other electron rather than share it. So you end up with chlorine being covalently bonded to oxygen and then oxygen stealing on the other side. This is your first polyatomic ion. ClO minus 1 is called hypochlorite. Now look what happens. We have a new type of bond called a coordinate covalent bond. Oxygen still needs 2 electrons. Chlorine has plenty. So what happens is that chlorine says, hey, you poor thing, you're looking for 2 electrons. I've got these extras just sitting here. Why don't you just scooch over here and share these electrons? And so it is. It's a coordinate covalent bond. That means we have another polyatomic ion, ClO2 minus 1, and we call that guy chlorite. You see, we can do this again. If we put an oxygen on the left-hand side here, it's still a minus 1 because oxygen's still grabbing that electron. And this is ClO3 minus 1 chlorate. Yet one more oxygen can be added to the bottom, and that makes it ClO4 minus 1, and that's perchlorate. The per refers to 4. Those are your first 4 polyatomic ions. All with a minus 1 charge, because oxygen is stealing that electron on that same side. Now we'll learn that you can actually replace the chlorine with fluorine or bromine or iodine, any of the halogens, and then you get an extra 12 polyatomic ions, like fluorite, hypofluorite, fluorate, or bromate or iodate. Let's move on to another one. Let's draw the sulfates. No, let's not do that one. Let's do hydroxide. If we have the oxygen here, he's got 6 valence electrons. He's going to share with hydrogen on one side, and oxygen's going to steal on the other. That's always how we make a polyatomic ion. Oxygen shares with one side, steals with another. That makes hydroxide, OH minus 1. Notice I drew it OH, not HO. That, when written 3 times, would be a holiday idea, or if you drew it singly, I don't know, it's an occupation. Phosphorus has 3 polyatomic ions, and let me show you those. Phosphorus has 5 valence electrons, there's his X's, and we could scooch an oxygen here, and phosphorus will share with the oxygen on one side, and oxygen will steal with the other. Great. Now we're going to add another oxygen down here on the bottom, and he's going to steal an electron, and then we're going to add one more oxygen on the left. and he will steal an electron. Notice phosphorus needs 3 electrons. For each electron he needs, he's sharing with an oxygen. And each one of those oxygens are stealing electrons. That's phosphite, PO3 with a -3 charge. Now you see there's a spot up here on top that we can add this oxygen to. So now it's PO4 -3, which is phosphate. Those are the 2 polyatomic ions of phosphate. I said earlier that there's 3, but that was a big fat lie. There's only 2. Okay, so let's create the list now. Like, this is the list that you need to know, and starting on Thursday, we'll have a quiz every day. The guys that are -1, and you can just copy this list down. Hypochlorite is ClO, it has a -1 charge. Chlorite is ClO2 with a -1 charge. Chlorate is ClO3 with a -1 charge. And perchlorate is ClO4. All of them have a -1 charge, and it is crucial to know the charge. Let's see, we also had hydroxide. We already drew hydroxide. It's OH with a -1 charge, not HO. And then permanganate, purple, it's purple permanganate. It's MnO4 -1. Acetate is H2, H3O2 -1. And then we have a pair. Nitrite is NO2 -1, and nitrate is NO3 -1. Now we have a couple that we can derive from the other ones, but I'm going to add it to the list anyway. Hydrogen carbonate, HCO3 -1, is also called bicarbonate on the streets, like baking soda. And the same with hydrogen sulfate. It's HSO4 -1. It's called hydrogen sulfate, but it's also called disulfate on the streets. And we have dihydrogen phosphate because there's 2 hydrogens. Now for they're -2s. Okay, now for the -2s. We have sulfate, SO4 -2, and then we have sulfite, SO3 -2. Carbonate is CO3 -2. And oxalate is C2O4 -2. Chromium has 2 polyatomic ions. Chromate is CrO4 -2, and dichromate is Cr2O7 -2. And to that we can add silicate, SiO3 -2. It's identical to carbonate because silicon and carbon are in the same column. And then hydrogen phosphate, which is HPO4 -2. And we're almost finished. We have one pair that's -3. We've already drawn them. Is phosphite, which is PO3 -3, and phosphate, which is PO4 -3. Look at that, I wrote that wrong. Phosphate is PO4 -3. +1. We have one polyatomic ion that's +1. His name is ammonium. He ends in IUM. Ammonia, like, whoo, smells like ammonia. That's NH3. So that's it. That's the list of polyatomic ions. We do need to know them. We do need to know them quick. And that's it. Don't drink and drive.